Evening all. Now I'm working on the bicycle generator project again, and I've managed to get it to display a number on the LED matrix and also the word watts. Now that number is just the raw data coming from the analog to digital converter, and the potentiometer down here, which is connected into A0, is actually set to maximum. So that number should be 1023, and it's not. It's actually around about 1,000, and I was curious to know why. Now, in part 1 of this video, I mentioned that there's a little switch on the side of the board. There it is, just between the two rows of pins. And I'd set it so that the red VCC pins, that row up at the top and also the little row at the bottom, are receiving 5 volts from the switch mode power supply, the one that's underneath the Nano there. But the Nano itself is referencing all its analog measurements to its own 5 volts, which is coming from the analog regulator. So the problem here must be that the switch mode 5 volts is a bit lower than the analog regulator 5 volts. So when the analog to digital converter is measuring the maximum value with the potentiometer fully clockwise, it's actually not quite getting the full 5 volts, and that's why we're not getting the full 1023. Now look what happens when I move the positive connection of the potentiometer onto analog 5 volts. So I've moved the top of the potentiometer, which is actually that orange wire, to pin 2 of the ICSP header, which just happens to be analog 5 volts. And now on the display, we're getting a reasonably stable 1023. So it's fine if the potentiometer takes its 5 volts from the same supply that the microcontroller itself is referencing the analog measurements. Now I've turned the potentiometer down a little bit, and there is a little bit of noise. You can see that it's going from about 1003 down to about 99 something. It's difficult to see, so in fact a way to check this is to switch on the serial monitor, because I've got the data coming out of the serial monitor. So if I grab a bit of data and then stop the scroll is what I meant to do. So we can see that the lowest values are 997 and the highest values are about 1004, it would look like. So there's noise of about 7 digits there. And now I've put the potentiometer positive back onto that digital, the switch mode 5 volts, and turn the potentiometer up to full. And we are now getting more noise. I've just captured a little bit of it, and we're getting at the lowest 990. There's a 988 there, and at the highest 1007. So what's that? That's 19 digits of noise. So there's a lot more noise when the pot is on switch mode 5 volts than there is when it's on linear 5 volts. Now that row of red connectors at the top there, the digital 5 volts, doesn't really matter if it's on the switch mode power supply, because digital signals have huge noise immunity. They're either 0 or 1. So that could stay connected to the switch mode power supply, and it's going to need to be for this project because I'm drawing quite a lot of power to light all my LEDs. But what I really want to do is connect those 6 VCC red connections at the bottom there, the analog ones, to the linear, the analog 5 volt regulator. So let's have a look at the back of the board. So this looks pretty easy to do actually. This line coming down here runs through the VCC, the red connectors for the 6 analog pins, and then it runs up here through all the digital VCCs. So it should be relatively easy to cut the track at this point here, just put a small break in there, and then route these 6 connections round to 5 volts at this point, which is the output of the analog regulator on the Nano. And I can't see why I would ever want to take measurements using a VCC different to the reference VCC for the A to D. It doesn't make sense that this line is connected to anything other than analog 5 volts. So I'm going to make that cut, I'm going to make that change and modify this board. So there's my mod, a break in the track just there, and then a wire link running round to analog 5 volts, so that VCC for the A to D inputs is now always analog 5 volts, the same voltage as the A to D's reference. So there it is, my modified board, and now the A to D inputs have the analog linear 5 volts, and the digital pins at the top have the high current switch mode power supply 5 volts, and so I'm able to draw lots of power for my display, but I'm getting the nice stable A to D measurement from 1023 all the way down to 0, and even at the midpoint of about 512 we're not getting too much noise on there. There is a bit, there's what was it, about 6 digits of noise, but I think that's, well, it's more acceptable than the 19 digits of noise I was getting on the digital.